Hello students, I'm coming to you with the next video lecture on Chapter 3, which covers measures of central tendency and variability. In this video lecture, we will discuss the concept of measures of central tendency, which include mean, median, and mode. We will also discuss the impact of outliers or extreme scores on measures of central tendency and the application of levels of measurement to measures of central tendency. At the end of this video, I will invite you to check for your understanding of these concepts. In terms of learning objectives, by the end of this video, you should be able to understand and explain the concept of mean and the three different types of means. Understand and explain the concept of median. Understand and explain the concept of mode. Understand and explain the concept of outliers and their impact on data and decisions regarding measures of central tendency to report. And apply the concept of levels of measurement and outliers in deciding which measures of central tendency to report. Before we get into the topic of measures of central tendency, I'd like to point out that this is part of a larger topic within the field of statistics. Measures of central tendency are often discussed within the context of measures of variability as well, which is what we will cover in the next video lecture. Measures of central tendency include mean, median, and mode. Measures of variability include range, variance, standard deviation, mean deviation, and interquartile range. Both measures of central tendency and variability help us to summarize our data. Although multiple data points are entered into a data set, measures of central tendency and variability are intended to produce a single number that describes the shape of our data. Now let's get into the topic of measures of central tendency in greater depth. Again, in this video, we will be discussing measures of central tendency, which include mean, median, and mode. We use measures of central tendency to provide a mental image of the most central or typical values within a distribution. These measures help us to locate the center of numerous data points that make up a distribution of data. These measures provide a summary of what we can expect from the data set as a whole. When data are normally distributed, all measures of central tendency fall at the center of the distribution of data, where the mean equals the median and the median equals the mode. When data are negatively skewed, or when the tail is pointing to the left of the distribution, typically the mean is less than the median and the median is less than the mode. When data are positively skewed, or when the tail of the distribution is pointing to the right side, typically the mode is less than the median and the median is less than the mean. In this illustration, I draw your attention to the direction in which the tails of each distribution are pointing. For a negatively skewed distribution, the tail is pointing toward the negative side. However, the cases mostly fall to the right-hand side of the distribution. On the other hand, for a positively skewed distribution, the tail is pointing to the positive side, while the cases mostly fall on the left-hand side of the distribution. Finally, when data are normally distributed, typically the mean, median, and mode are all equal. We will go into greater detail about this in Chapter 4. Now let's discuss the concept of mode. Mode is the value that occurs most frequently in a distribution of scores. It is determined by counting the number of times each value within the dataset occurs. When there is only one mode, the distribution is called unimodal. When there are two modes, it is called bimodal. When there are three or more modes, it is called multimodal. As shown in this illustration, the number of modes is determined by the number of peaks in the distribution. If the distribution has only one mode, there is only one peak. When there are two modes, there are two peaks. And when there are three or more modes, there are three peaks. As we can see from this chart, the variable life satisfaction has multiple modes. This is the histogram for the variable life satisfaction. I draw your attention to the bottom of the bell curve, which is superimposed on our histogram. Notice that the curve is not quite touching the x-axis. This is because the distribution for life satisfaction has multiple modes and actually looks something like the graph on the right-hand side of the screen when it is shown in its entirety. Of the three measures of central tendency, the mode has the fewest requirements for its use. It can be used with all four levels of measurement. For nominal and ordinal level variables, the mode is typically a word, although a code is assigned. For ratio and interval level variables, the mode is typically a number. So as we can see in this table here for the variable race, which is measured at the nominal level, the mode is actually a code. And the same is true for the variable education, where the mode is also a code. So we would have to refer back to our code book in order to determine what the word is that is represented by each of these codes. However, for the variables self-esteem and depression, which are measured at the interval and ratio level, we can see that the mode is actually a number that has mathematical meaning. The mode is useful for determining which values appear most frequently in a given distribution. But frequency counts may not always provide the best representation of data, especially for variables measured at higher levels, such as the interval or ratio level. So now let's talk about median in greater detail. The median is the middle score in a distribution. It divides an array of values into two equal halves. So here again, we see the concept of array at play. To calculate the median, we would first need to arrange the data in an array. For an odd number of cases, the median is the middle score. For an even number of cases, the median is the sum of the two middle scores divided by 2. If data are measured at the interval or ratio level of measurement, the median is often a good choice to describe and represent the distribution of data. One advantage to reporting the median is that it is not affected by the presence of outliers as much as the mean. So here's just a brief note on outliers. An outlier is an extreme value that lies outside most of the other values in a data set. Usually, the presence of an outlier indicates some problem in the data set. Consider this set of values. The two sets of scores are identical except for the first score in the distribution. The set on the left shows the actual scores. The set on the right shows what would happen if one of the scores was an outlier or extreme score, such as a 0. Notice that with the outlier included in the distribution, the mean changed. However, the median did not change and remained stable. Each data point in a distribution contributes equally to the calculation of the mean, even extreme scores or outliers. The median, however, only considers the scores in the middle of the distribution and ignores any outliers that exist at the extreme ends of the distribution. This is the advantage of reporting the median over the mean, particularly when outliers are present in the data. Now let's discuss the mean in greater detail. When a variable within a data set is measured at the interval or ratio level of measurement, the mean can also be used to represent or describe the distribution of data. There are 3 different types of means that are discussed in your text, and they include the arithmetic mean, the trimmed mean, and the weighted mean. Unlike the median or mode, the mean is very sensitive to outlier scores, the arithmetic mean in particular. Data should be carefully evaluated for outlier scores before a decision is made to report the arithmetic mean. The arithmetic mean is the most common type of mean. It is the sum of all values in a distribution divided by the total number of values. It is most often referred to as the average. The trimmed mean, on the other hand, is designed to minimize the effects of extreme outliers. To achieve the trimmed mean, a small percentage of the values in an array are excluded. Then the remaining values are averaged. This average is called the trimmed mean. Here's one example. In the distribution of scores to the right, the arithmetic mean for the first distribution of scores is 3.95. In the second column, the 2 scores on the extreme ends of the distribution have been excluded, and the trimmed mean was recalculated based on the remaining scores. The trimmed mean is 3.78. This is an example of a 10% trimmed mean. And there are other types of trimmed means as well, such as a 5% trimmed mean. Determining which trimmed mean to use really depends on how conservative you want to be in your estimation of the mean. The weighted mean is similar to the arithmetic mean, except instead of each value contributing equally to the final average, some of the values hold more weight or are more important than other values. One of the best examples of this is the calculation of course grades in university settings. In this example, although each assignment contributes to the final course grade, they are each weighted differently. Each assignment is figured into the final course grade according to its weighting factor. Now let's discuss some considerations in measures of central tendency. There are 2 factors to consider. One is level of measurement, and the other is presence of outliers. With interval and ratio level variables, reporting the arithmetic mean is a matter of judgment. If outliers are present and will severely distort the results, the median or trimmed mean should be reported instead. It's important to keep in mind that we have an ethical obligation to represent data accurately and not in a way that is misleading. Now let's discuss the relationship between levels of measurement and measures of central tendency. So in general, the takeaway from all of this is that we must take into consideration the levels of measurement of each of our variables before deciding which measure of central tendency to report. So for example, if we know that our variable is measured at the nominal or ordinal level, then we know that the mode is most appropriate to report. However, if our variable is measured at the interval or ratio level, we know that we can report all three measures of central tendency, which include mode, median, and mean. So we must take into consideration levels of measurement, which here again we see applied in this chapter as well as in previous chapters. So in summary, in this video, we have discussed measures of central tendency, which include mean, median, and mode. We've also discussed the three different types of means, which include arithmetic mean, trimmed mean, and weighted mean. We have also discussed the impact of outliers or extreme scores on measures of central tendency. And finally, we have discussed the relationship between levels of measurement and measures of central tendency, and how we utilize levels of measurement in order to determine which measures of central tendency are most appropriate to report. And now is the point at which I invite you to check for your understanding of these concepts. You can do this in one of three ways. By either completing this form on the left and simply clicking submit, or copying and pasting this link into your web browser, or scanning this QR code in order to complete this survey. Here is a crash course video that you might consider watching on measures of central tendency. I hope this has been helpful, and I look forward to seeing you in the next class.